Ask an AI with no tool to multiply two large numbers, and it might get it wrong. Ask it what the weather is right now. It has no idea. Ask it to look up a customer record in your database. It simply can't. Without tools, AI agents are surprisingly limited. They can reason, they can generate text, they can even plan. But they can't act on the real world. They are stuck inside their own head. So, how do we fix that? Well, we give them tools, and that changes everything. Welcome back to Agentic AI Simplified. This is episode 5, What are AI tools? If you're finding this series helpful, hit that like button and subscribe so you don't miss the next one. Let's start with the baseline. A large language model on its own works like this. Text goes in, text comes out. That's it. It's a conversation machine. And look, that's incredibly powerful for a lot of things: writing, summarizing, brainstorming, coding assistance. But here's the problem: an LM has no real time data. Its knowledge is frozen at whatever cutoff date it was trained on. It can't do precise computation. It's predicting tokens, not running a calculator. And it has zero access to external systems, no databases, no APIs, and no file systems. The model is thinking in a sealed room. It can only work with what's already inside its head. For an AI agent that needs to actually get things done in the real world, that's a serious limitation. So, what exactly is a tool in the context of AI agents? Think of it this way: the LLM encounters a problem it can't solve on its own, say multiplying 847 by 293. Instead of guessing, it recognizes that this is a job for a calculator. It formats a structured request, essentially saying, "Hey calculator, multiply these two numbers." That request goes through a tool interface, which is just a well defined contract describing what the tool does, what inputs it expects, and what it returns. The calculator executes, returns the precise answer, 248,171, and that result flows back to the LLM, which incorporates it into its response. So here's the formal definition. A tool is any external function that an LLM can invoke through a structured interface to perform actions it cannot do natively. The key word there is structured. The LLM doesn't just randomly call things, it follows a defined protocol. Now let's look at how tool calling actually works under the hood. This is the mechanism that makes it all possible. A user asks, "What's the current stock price of NVIDIA?" The LLM reads this and makes a critical decision. Instead of hallucinating a number, it recognizes, "I need real-time data. I should use a tool." So it generates a structured tool call. Think of it like a JSON object. It specifies which tool to use, in this case, web search, and what parameters to pass. This structured call gets picked up by the execution runtime, the system that actually manages the agent. The runtime dispatches the call to the web search tool, which goes out and hits the internet and returns structured data: the current price, the percent change, real live information. That result flows back to the LLM, and now the model has actual current data to work with. It composes a clean, accurate response. No hallucination, no guessing, just precise, grounded information. That's tool calling in action. Let's look at the most common types of tools that AI agents use. Think of this as the essential toolbox. First, calculators and math tools. This might seem basic, but remember, LLMs are language models, not math engines. For anything requiring precision, arithmetic, unit conversions, statistical calculations, you hand it off to a dedicated math tool every time. Second, web search and retrieval. This is what gives your agent access to current information: real-time search results, breaking news, fact-checking against live sources. This is how you solve the knowledge cutoff problem. Third, databases and knowledge bases. This is huge for enterprise applications. Your agent can write SQL queries, look up customer records, check inventory levels. It can interact with your organization's actual data. And fourth, APIs and external services. This is where agents start to take real action in the world: sending emails, creating calendar events, posting messages to Slack, triggering a deployment pipeline. The possibilities here are essentially limitless. When you connect all four of these to an LLM, You've transformed it from a text generator into something that can genuinely operate in the real world. So how do you actually build this in code, and how do you give an LLM a tool? First, you write a standard programming function. For example, a Python function that checks the weather. Next, you write a JSON schema that describes this function. It defines the name, a description of what it does, and the exact parameters it requires. When you make your API call to the LLM, you pass your user prompt as usual, but you also pass this schema in a dedicated tools array. The LLM processes the prompt, looks at the available tools, and instead of generating text, it returns a structured tool call requesting the weather for that specific location. Your code executes the actual Python function, gets the result, and passes it back to the LLM so it can compose the final answer. So yes, let's bring it all together. Tools are what transform an LLM from a smart conversationalist into a capable agent. Without them, the model is stuck in a sealed room with only its training data. With them, it can take real-world action. The mechanism is elegant. Tool calling uses structured interfaces. The LLM describes what it wants to do in a defined format, the runtime executes it, and the result flows back. And the core toolbox, calculators, web search, databases, and APIs, covers an enormous range of tasks. But here's the thing, knowing about individual tools is just the start. In the next episode, we're going to zoom out and ask, how do you actually organize all of this? How do you build a complete system where agents, tools, memory, and planning all work together? Thanks for watching. If you enjoyed the video, do like and subscribe so that you will never miss an update, and I'll see you in the next episode.